Welcome everybody. This is a really exciting and really fun webinar to be talking about today. We're going to introduce you to Neo4j Bloom. And as we go through this, first I'll sort of set the stage or the intention for Bloom. We'll talk about its fit within the Neo4j product family. And then the biggest thing we'll get into fairly quickly is how Neo4j Bloom helps us connect with other audience members and deliver graph information to a larger community of users beyond what you might be familiar with if you've been using Neo4j desktop or the Neo4j browser to write and manipulate your graph database. Then we'll walk through Bloom itself, and I'll give you a couple of demo examples, and we'll kind of take it from there. So very quickly, just some background on Neo4j. A little bit of our current situation is we are enjoying a great surge in the adoption of graphs, both from our customer standpoint as well as partnerships within the market. But the adoption of retail firms building recommendation engines and some really other very clever capabilities, like I said, in retail. We've got 70% of the top 10 retailers. We've got almost 20 of the top financial services firms out of the top 25. 80% of the top software vendors are already enjoying and using Neo4j. When you combine our startup, the vendors in our startup program with the number of enterprise customers that we actually have now, we're pushing 1,000 organizations, enterprise organizations that are in the Neo4j family. The participation of the open source itself is incredible. 13 million plus downloads and Docker container pulls of the software so far, and over half of our 270 enterprise organizations carry more than $1 billion in revenue each. And you can see some of our highest profile customers are listed here, including LinkedIn and Microsoft, UBS, Comcast, eBay, Walmart, Lufthansa, Cisco, etc. So really great adoption of Neo4j, and the reason why is because at our core, we deliver a native graph platform that helps you reveal how your data might be connected and then store, query, and operationalize that information. And what it helps you do is set context for all kinds of different applications on this graph transactions kind of side of our platform diagram here. So at its core is the Neo4j database that's been around for nearly 11-12 years so far in the market. It is tried and true. It is the #1 graph database on the planet right now. It's known for its very high performance in building real-time contextualization applications. Like I mentioned a moment ago, it supports ACID transactions, so everything that you do inside of Neo4j is indeed transaction safe and dependable. It gives you that agility of not having to predefine a schema, but manipulate and create your database and your schema-like environment very easily. Through the course of 2018, we've introduced a number of graph algorithms. You can see that at neo4j.com, and all of this is geared towards helping developers build very clever next generation applications to support digital transformation exercises, to build off of your machine learning and AI experiences, to operate globally at scale, and really drive this whole adoption of the graph paradigm. So some of the things that we've done since bringing the database itself to market about 10 years ago, as an open source technology, is really keep building off of that particular database. Some really interesting things we've done I want to highlight are things like the Open Cipher initiative. In 2015, we introduced the world to an open source Decipher query language as the preeminent de facto standard core query language for graph manipulation. Fast forward to this year, and we've also introduced the GQual Manifesto, which you can find at gqualmanifesto.com, and that in itself is our call to arms of the entire graph industry to help promote a common universal language of graphs, and we're making great headway there. Look for some more announcements of that in the future. But 2018 has been a really busy year. We introduced the industry's first native graph platform towards the end of 2017 at Graph Connect in last October. We've introduced the graph algorithms, the Neo4j desktop that gives developers their own copy of Neo4j Enterprise to build their applications. But then you can see what we've done in 2018. We've created the early adoption for Neo4j Cloud. We've introduced Neo4j Bloom in the second quarter. We've open sourced Cypher for Apache Spark and Cypher for Gremlin, as well as written out this GQual Manifesto. So some really, really big things there. And then if you look into what we're going to be working on in 2019, again, some really, really interesting and clever capabilities there. So the core advantage of Neo4j and of the graph architectures in general, if you compare it to a relational technology that's really designed to simply store and retrieve your data, versus if you take that same data and put it into a graph environment, what you start to reveal is the connectedness of that data. And the connectedness is really what drives your core data value. I like to use Metcalfe's law of the network to really illustrate how you can develop more and more value out of the information that you have today simply by using Neo4j to reveal the connectedness of that data. And what's really interesting about connectedness is how it sets context for a variety of different use cases. Contextualizing a buyer's pattern on an internet store, for example. Ryan, did you know that there's a book out there called The End of Averages, and what it promotes is this idea that every human being is indeed unique, right? And the uniqueness of all these characters, when you're building a recommendation engine, you have to contextualize the buying habits and the buying patterns of that one individual. You can't do an averaging like say all of our customers behave this way, because you know what? They don't. So really, I've been listening to lots of audiobooks lately, so that's just one of my favorites. Another favorite, of course, is Stephen Johnson's Where Good Ideas Come From. That one talks about adjacent possibilities and how innovation happens when you get related items together, but they might not necessarily be exactly contextualized or associated with each other. But when you create the possibility for them to join up or to find a missing connection, then you get the kind of that spark of innovation. It's a really interesting set of storylines. So if we look at this Metcalfe's law of the network kind of concept, if you look on my left-hand side, I've got a graph representation, a mini graph there of about 5 hops. Well, in all kinds of other graph systems, 5 hops is a lot, right? But when you're thinking about contextualization, 5 hops is nothing. When you look at the right-hand side of this picture, hundreds of hops are where all of that contextualization value really, really lives. And you want to be able to explore all of that capability. And guess what? That's what Neo4j Bloom is for. So you'll recall that we invented the labeled property graph model. What this means is we have the core fundamentals of the graph are you have nodes that can have names and labels to classify what they are. They have native indexes, so it's very, very fast to both put them into the database and then, of course, retrieve the information or append the information to them. We have relationships, and each relationship has its own label as to what that relationship means. And then there's properties for both nodes and relationships. And that's really a list of attributes. Like in this particular case, I have 2 people named Dan and Ann. I have another node that Ann owns the Volvo and Dan drives the Volvo. And of course, we have new features in Neo4j are the geospatial capabilities. So I can tell you where it's parked too, at latitude 37.5 degrees and longitude 122.3. And that, of course, is where? It's here in San Mateo. So connectedness is really this core idea of what differentiates Neo4j from all of the other kinds of players, whether they're relational systems or the non-native graph systems, other NoSQL type databases. And really what you can see here is Neo4j itself is optimized up and down for how you think about graphs, how you visualize graphs, how you write them out and code the graph behavior, how the system itself computes your graph information and even stores your graph information. All of that is optimized natively for graph workloads. By contrast, what you get with other systems is at some point in time, there's some kind of transposition, there's some kind of remapping of, how do I fit the storage model, the original storage model to support a graph workload? It gets clunky. Oftentimes it creates situations where the data could become corrupt. It just not optimal for a graph style of workloads, because preserving and maintaining the connectedness, those connections, those relationships is really important in the world of graphs. So the way we tend to look at it is these different paradigms. There's your collection-focused kinds of concepts. Your NoSQL databases fall into that. Your relational databases more so fall into the collection-focused kind of systems. They're great at aggregating systems. They're great at basic store and retrieval kinds of operations. But they really don't reveal or start to focus on the connection orientation of data itself. Now, these are highly complementary types of systems and environments. But when you really look at the way Neo4j is designed, we build on data relationships, and it's a model that is actually very naturally intuitive. It's easy to maintain. It's easy to write queries for it, and it's designed for being ultra high performance. So when you need to build a real-time recommendation engine, such as what eBay and Walmart have done and other retailers have done, everything operates in milliseconds kind of timing. And of course, we do believe graph is a unique paradigm, and just look at kind of some of the assertions that are happening in the market, where Forrester recognizes that 69% of enterprises are planning to or have deployed their first graph application, and that was designed about 11 months ago. In February, in the critical capabilities for database management systems for analytics, Gartner recognized that the most widely stated reason why customers select Neo4j is to drive innovation. And then finally, Frost and Sullivan recognizing that other graph tech, Neo4j and other technologies may signal that this idea of connectedness is indeed a separate paradigm from NoSQL types of systems. So really what we're building towards here is helping define how graphs can really benefit you and remove us from the noise of NoSQL systems and other relational type systems. Now, last year we introduced the Neo4j platform architecture, the platform design. And when we came out with this, what we were really intending to do was focus on illustrating how graphs can help organizations and help different types of users across all of these organizations. We've been traditionally focused on open source developers and those building these very, very clever recommendation systems, et cetera. So the developers, the data administrators, those supplying drivers and APIs to make Neo4j part of the fabric of these applications has been, like I said, really the focus that we were carrying forward. Then we started to work on graph analytics and explain to the world how the 300-year-old kind of paradigm of graph theory actually does apply today. And so we supplied analytic tooling in the form of graph algorithms, in the form of other analytic toolkits. We're also focusing on the enterprise data hub, the big data people, right? All of these folks who are looking to derive value out of the information in their data lakes. Well, we have a number of different tools for performing this data integration exercise or a data ingestment exercise in order to get your information into the graph world and start to reveal those connections themselves. Now, all of that's great. I have capabilities for the analyst, the data scientist, that IT person, the enterprise data hub person, and guess what? We're not going to talk about any of those guys today. what we want to talk about is the business users and how are we going to end up visualizing and discovering what the core graph can do. And that's really what Neo4j Bloom is all about. It's designed as a communication tool, right? We were trying to figure out, when we surveyed our customer base, we said, how would graph visualization be useful for you? And so some of our customers said, well, it's going to help me think about my data from the perspective of connectedness. I'm going to be able to use it as a development tool for working with the graph information. I find that oftentimes I have to explain what the heck a graph is or what the logic was behind the graph, and I need a communication tool that helps me carry that idea forward. I need an interactive tool for exploring the relationships as they evolve and envelop, because when you start to operate the graph, right, you start to look at things and continue to explore in the data itself. You navigate around this idea of the graph itself. Sometimes I need to print things out, report them. Sometimes I need an analytic tool to help me, reveal critical paths, shortest paths, critical trends, discrepancies, odd patterns. So this visualization capability, especially when you're doing it from the perspective of connectedness and not building a pie chart or bar chart, but this idea of connectedness really starts to reveal information about the graph that and about your data that you may not have spotted before. So let's very quickly walk through what I'm going to continue to talk about in terms of what Neo4j Bloom does before we show it to you. So number one, Neo4j Bloom, we shipped it in May. It came out with these ideas of perspectives. I'll go into this in a little bit more detail in a second. It gives you this business view of the graph itself. And then perspectives can actually be used as different types of views of a graph depending on what your interest in the graph happens to be. So I could create departmental views. I could create views that hide personally identifiable information. I could use graphs that illustrate particular stylings of the graph itself. As a visualization vehicle, we had to work a lot in being able to collect and then deliver all of this connectedness information as nodes and relationships, which of course made us get into GPU accelerated kinds of visualizations, because this is a highly graphical tool, and we wanted it to render really almost explosively as you're looking at the system. I can explore the graph itself in a directed kind of manner. I can select different items of it. I can expand or dismiss elements of the graph. I can search for paths within the graph. I'll show you that in a moment. So this exploration activity is actually really fun. So when I get a particular node or a particular relationship that I want to dive deeper into, I actually have an inspection panel that allows me to look at what the nodes are, what the properties of those nodes are, and look at its adjacency from neighbor to neighbor there. And I can even edit the graph directly in the from within this interface. So kind of handy there. As I said, I can edit, create, edit, delete, apply changes in a code-free manner, right? So remember, we were targeting this particular product at your everyday user, right? Sometimes they might say, hey, I need to clean up the data. There's a particular address that's wrong, or a particular we've created a relationship that is mislabeled or something. I can edit and make those changes. And then the final piece, which is really fun, is when we built this, instead of having to know Cypher, instead of having to know very much about how graph behaves, we created our own, let's say, near natural language search capability. So it gives you full text capability for how to manipulate and look at the graph, and then it gives you hints and clues as to what the graph pattern that you might be looking for actually is. And the cool part is that as a Neo4j power user, you can actually insert your own Cypher statements into this pattern suggestion capability, so that you can help guide your everyday users into what's good graph navigation or appropriate graph navigation. So when we look at, what does it really produce and what are kind of some of the elements of Neo4j Bloom, number one, high fidelity. It's designed to show thousands of nodes all at once on a screen. So unlike other products that get very difficult to show the cluster density or the different groups of related information like this diagram is doing, Neo4j Bloom is geared towards demonstrating exactly that. You can navigate as you go through and use Neo4j Bloom. What you end up doing is navigating from scene to scene. Every instruction that you type in as a search query or as an action that you take inside the interface, you're painting a particular scene for what you want to review. So and that can get played back later. This idea of property views and this text-based search capability, the suggestions, as I mentioned before, these phrase history, etc. Right, all of these are capabilities built within the Bloom interface. Some specific elements that I'm going to end up showing you that I really want to highlight. When we start typing into and exploring the graph for the very first time, we're going through that prompted search box up in the upper left-hand corner. When I want to look at a particular property or a node or relationship, I'm going to go into the property browser and editor and look for that information. You'll see that every one of these nodes in the diagram is both color-coded and iconified. So this makes the ability to communicate what each node means really easy, in addition to its labels and other information that those nodes can contain. And you'll also see that when I'm navigating the interface, I can highlight particular nodes. I can pan in, I can pan around, I can zoom in, I can select them, I can clear the canvas, and then I can say expand what's related to me right here on this particular set of nodes that I'm looking at. So some very interesting things I'll show you in just a minute. Now here's an example of that high fidelity kind of concept I was talking about before. When we looked at the Panama Papers data set, right, that's of course the international consortium of investigative journalists. They keep continuing to break new and more newsworthy items. First was the Panama Papers, then the Paradise Papers, and they continue to identify where folks are hiding their taxable income in a variety of different locations. Well, in this particular case, what I looked for from the Panama Papers data set was the officer named Appleby. And Appleby is one of those core constituents involved in the Paradise Papers leak. It was the law firm that was the victim of leaked information and that the journalists got their hands on. So who's related to Appleby, right? Interesting search inside of Bloom, and this is what that looks like. All these 5,072 nodes identified here on this particular graph. So, like we said, very high fidelity perspective of what you can look at inside of Neo4j Bloom. So now let's talk about these perspective ideas. This is pretty cool. Graph perspectives allow us to manage the visibility of what a user is allowed to see or not see inside the graph. So it reveals the right information to those right users. So there's need to know details, like if I'm looking at my organizational structure, I can create departmentalized views. I can, as I mentioned before, I can mask PII data. I can look at structure only, right, which is kind of your schema view of the graph, and then I can look at interesting collections of nodes and relationships. This rich entity kind of idea, trucks with packages on them, or people with aliases for what they're called, blog posts with comments, right? Those kind of naturally identifiable groupings. We can create a perspective to highlight each one of those. So let's look at what I really mean. And my example here is going to take the Northwind database, right? Something that we all should be quite familiar with out there if you've been operating on any database, arguably for the last 25 years. Northwind is basically a product order detail kind of and employees who sold the product type of data model. So when there's my Northwind perspective of this. Now here's the graph perspective of Northwind itself, and you'll see that I've got is in terms of my employees, Buchanan reports to Fuller. In terms of my locations, I've got Buchanan covers a particular territory in Providence and the East Coast. And then I've got Buchanan sold a particular product, which was shipped via FedEx to the customer. And then I've got details about that order and about the products that make up a particular order. So this is the graph, the overall view perspective, the meta view of Northwind. And you can see my color coding is kind of interesting here because each one of these represents a particular type of data. The red, the topmost one, is the product, right? And then you've got a category of product. You've got the supplier to the product, the customer of the product. The green is the order for that product. And then there's order details, right, that go into the order itself. I've got my employees, where they're located, what territories they're in, the region, shipper, etc. So we're fairly familiar with this, Ryan. You want to see something else here?
Sure.
Let's look at a new perspective. Let's say we're in the purchasing department of Northwind. And so here, what I really care about are products, the categories that of the products that I've been selling and where I get them, right? Because I need to make sure I'm sourcing enough product for myself. All I really need to look at in that graph are these three nodes here and how they're interrelated with each other. Now let's look at the shipping department, right? Completely different organization in the company. Here I need the products themselves, of course, too. The order details of where those products are coming, where they're coming from, the order itself of where it's going to go, right? Who the customer is and how I'm going to get it there, right? Pretty basic, but another perspective that's specific to shipping. When I look at sales, right, as we mentioned before, this one gets a little bit more intricate because this is almost like my Salesforce view, right? Is when we look at the whole CRM environment. So I've got my sales rep, I've got their, the reporting structure, their sales manager. I've got what territory they're operating in, what orders they're taking, who their customers, their major accounts happen to be, how many orders they might be placing, et cetera, right? All of these are elements of this sales department perspective. And then finally, HR just wants the the org chart. So I'm highlighting my org structure of Andrew Fuller is managing Stephen Buchanan is the basic fundamental here. And finally, when I want to expose something to the customer, I can show them their view of the same graph, right? And externalize that for them. So it's themselves, what product categories they're shopping and buying, what products they're buying, what order it was attached to, and when was that sent out to them. So again, all of these different perspectives are allowed and available. You can manage inside of Bloom itself. So let's look at the other really clever one is, of course, the graph search. It allows us to ask Bloom for specific details of what I'm looking for using these idiomatic phrases, right? Using these things that are close enough. So I'm looking for Tom Hanks movies, for example, or I'm looking how to get from Tom Hanks to Kevin Bacon, different ways in which to play the 6 degrees of separation game. But each of these are just are the fundamentals of the way that Bloom would be interpreting this kind of search phrase, right? It would look for nodes named Tom Hanks, which is likely to be, a movie star attached to movies, right? And then look for movies that have both Tom Hanks and Kevin Bacon in them. And that's how I'm going to get from Tom Hanks to Kevin Bacon. So let's look at very quickly a couple of our demo examples as we start to wind down here. These are fun, so let's play along. So the first example we're going to talk about is the fraud detection example. And the way that we're structuring this is I'm going to show you the fundamental perspective of the graph, and then we'll play around and operate within the graph. So I've got my my account holder has a phone number, has different bank accounts, has money transfers. Has loans, has credit cards, has addresses, etc. So we're going to look at, if I'm in the banking world, what are some of the anomalous things that I might want to visualize inside of Neo4j Bloom. So let's get going. So here we're gonna first look at, I've got my categories. So I want to go and say, I can zoom in and out. But let's find all the bank accounts first, right? So we're going to say, give me the account holder, and isn't that cool how it's popping everything immediately? And your first introduction to Bloom is really kind of a fabulous experience, right? it animates itself as as the data itself kind of blossoms right in front of you. So I'm looking at this set of account holders, and hey, wait a minute, what's up in that upper left corner? I've got one weird account. What is that? That looks like it's a bank account that has it's an account holder, but we want to let's investigate that some more. So I'm going to highlight this particular node. We'll zoom in a little bit, and this is going to tell me that as I want to see what's related to it, I inspect the 5 elements that are around it. So I have a credit card, I have the address at for this account, I have a social security number, this account holder has a bank account, and then of course we have phone number also. So let's look at our different labeling schemes here. So this is Valentina's information in the property sheet there. So that's actually who the account holder really is. And I want to make sure that this is properly represented inside the graph. So that was pretty helpful, looking at the misidentified node and then fixing that very, very quickly. So let's look at what Valentina's got here, and we'll expand this node again another pop it out another 4 sets of items and dive in. So we've got our account, our account with a balance and where it's located. We've got Margaret Muni has a social security number, and Valentina has a social security number, but that's weird. You see that?
I missed it.
Well, look, you got 2 people have the same social security number.
Something's up.
Something's up, right? That's unusual. So first illustration was, what's going on with Valentina's, node label itself. But then, we've got, wait a minute, an account holder or a social security number with more than one account. That's unusual. So let's investigate that. We're going to say account holder with social security number and then another account holder. And look, oh my gosh. This is giving us the illustration of all of the different social security numbers that have multiple people assigned to them. You know what that really means? That's an indicator of identity theft, right? Is they took the social security number, they've assigned it to multiple characters, multiple people, and maybe there's even other accounts that are associated with this. This is, like I said, it's kind of troubling that that actually exists. But what it's also illustrating, and this is a really, really fun part, what it's also illustrating is that fraud has a shape, right? And this is, and visually you can identify these things so rapidly, right? Because your mind is picking up on these anomalous looking things within the graph. So the shape of fraud is I've got multiple people with the same social security number. That's bad, right? But that took us all of what, 3.5 minutes to find, going through this particular example. So, like we said, really, really quick and dirty, a quick means to go through and look at what's happening in the world of fraud. Well, let's carry that a little bit further. We've got another example here, which is we like to call it the law enforcement example, but it's a really great illustration of some core properties of a graph itself. Have you ever noticed, Ryan, that graphs have people in them almost all the time?
Yep.
Right. And then you know what else they have? They have objects, right? Things in them. Objects could be your telephone, your computer, the systems that you're working on, right? A number, like I said, phones here. They have activities, like did you commit a crime in this particular case? And guess what? It happens somewhere. So there's always a location associated, or very often a location associated with the graph. So what we like to highlight this, oftentimes we call it the pole example: person, object, location, and activity or event, right? What's happening there? So let's look at what that's going to look like inside of Neo4j Bloom. So let's start with crimes, right? That's such a good one. So we'll start with, we'll type in crimes, and we've got a crimes with, let's figure out who where the outcome happens to be, what we're going to go. So we happen to be reading our list over here. The outcome is under investigation, and maybe there's a particular cop who's investigating all of these things. So we're going to dive in and say these are investigated by Officer Jones, right? And what we'll use here is the officer's badge ID number to figure out what what they've been up to, what they're working on. So let's dive into this. We'll take badge number 26-5 5234182, right? Just go for it. And let's see what we find. Well, we've got Officer Larive Devi, right, is our character here, and seems to be investigating all kinds of different crimes. We've got drug crimes, we've got theft, we've got criminal damage, we've got public orders. So as we expand this, let's look at drug crimes that are being investigated by this officer. And so here we've got the drug crime is involved in a particular event, 2 events. We've got a character, a party to these to the drug crime itself, because everybody's presumed innocent, right, until they're found guilty. And then the location where this particular drug crime happened to occur. So let's pick the other 2 drug crimes and see what we get out of this. And now wait a minute. So we've got different locations or different crimes themselves. So those are criminal events. And we've got the people that are associated. Those are the red boxes. So the blue boxes are the crimes themselves. And then wait, look, this character, Jack Powell, is involved in 2 of these drug crimes, right? A party to, as far as we can tell. And it's all happened at the same location. So here we go. We're zeroing in on some of these guys that really look suspicious to me, and all we're doing is navigating this fairly simple graph of all of these different events. So I'm going to clear that out, and let's look at some of the other. Remember, we talked about the search capabilities that we wanted to highlight. So here, what we're going to end up revealing is how I knew how to put the badge number in for that particular person. So all persons party to investigations by a particular officer, and that $ officer is the way I parameterize one of these particular search queries. So if I look for Officer Larive, and that gives me everything that they're working on. And wow, look at this group of criminals. Right, so we've got all kinds of investigations going on with many of the same sets of individuals involved with each other. We have, of course, the age-old premise of where do enforcement officials go first when they're investigating crimes? Facebook. Right, because criminals associate with criminals, and here's a pretty good illustration of exactly that. Right, is we'll figure out who the are there ringleaders here. This Philip Williamson knows everybody. So does Kathleen Peters. So does this Raymond Walker knows a handful of these folks. Brian Morales, right, is another one of these characters that is known by everybody involved in these different crimes. So overall, really useful graph that's mapping in these people, right? These objects of crimes and devices being used in crimes like emails and cell phones, etc. Where they're happening, the location, and the events themselves, the crimes themselves. So that's kind of the summary of our law enforcement example. And we'll do it finally a really quick one. Ryan, you're involved in all of our CRM systems here, right?
Right.
So that's Salesforce. That's the shipping manufacturing system, ERP system, the marketing automation system, Marketo, that we use. Yep. So how in the world do you and we're a global company, so you now have to adhere to GDPR, don't you? That's yes. Like your favorite project, isn't it?
Yeah, that took up a lot of time this year.
It did. So imagine, what's the data model for that look like? And how in the world can you tell if someone's in Marketo and they get all the way through to Salesforce and into our ledger? Right? How are you going to track all of that?
Yep.
You know what my answer is? You're going to use Neo4j Bloom. So let's look at how I might dive into exactly this kind of system. So I'm going to take an application type that gives me my 3 different systems we want to play around with: our ERP system, the CRM system, and the data warehouse itself. Because of course, you're good at these reporting requirements, etc. So let's expand the ERP system, and what we get is a number of different data elements that are inside of the ERP system. So these are the maroon items here are the columns in each of those systems for data-related items. And then when I expand the CRM application information here, I can see that part of the processes that we're operating that are attached to CRM include this receive and process product and pricing information. So what I can start to do is figure out a path between these particular nodes. So you see the path I just defined from one column through a process to another column to another system. I can figure out how the data warehouse has got the data warehouse product catalog information in it from the ERP system, which in turn was derived by the CRM application for how much do we charge the customer for that particular product. So you see that I'm going from my lower left-hand side data warehouse all the way around through ERP, all the way around back to CRM. There's my a very, very quick way to look at data lineage from one system, what columns, where it's coming from to another to another. Pretty handy, huh?
Yeah, I got it.
All right, so that kind of gives me now time to give you guys a quick way in which to get more information about what we've covered. So Bloom is a really fun product. We will be highlighting it a lot in New York City in about 2 weeks at Graph Connect, right? 2018 is in New York City at the Marriott Marquis. The main event is being held on September 21st. That's a Thursday, with additional events also happening on Friday for partners, for ecosystem members, as well as for by invitation for our executive summit. So anyone who's interested in this, please go to graphconnect.com. Register yourself up. It's going to be a power-packed event. We've got more than 50 sessions. Can you believe that? 50 sessions in one day.
Yeah, it's a lot,
right?
Year.
Including keynotes from Hillary Mason from Cloudera. She's their expert in AI and machine learning. We've also got Red Monk Stephen O'Grady speaking. So he's a very developer-centric, community-oriented analyst. Like I said, we've got tons of content. Many of our newest enterprise customers. One of the interesting pieces of feedback that we got was, I want more technical content out of you guys from Neo4j. Well, guess what? We have 20 different Neo4j people presenting at Graph Connect, mostly engineers, field technical people, product managers, right? Those are the folks that the community wanted to hear from and see and highlight. That's who we're bringing to Graph Connect. So that's my number one plug. My number two plug, you can contact us directly. info@neo4j.com is our email. You can go directly to the contact us form if you're in some other different location, and we'll make sure that we've got the right people on hand for you. We are right now offering trials for Neo4j Bloom. So one of the motivations here is, yes, come solicit us so that you can test drive out this product. And we hope to see you. I will be there. Ryan will be at Graph Connect as well. We're looking forward to this event. And again, please go to graphconnect.com for the agenda, for the speaker list, for the different topics we're covering. We're covering areas of graphs and artificial intelligence, graphs in Bloom, and of course, Neo4j 3.5. Right? Some of the newest capabilities there, like full text search. Right, are brand new capabilities that folks are really going to love. So anyway, that concludes my prepared remarks.